Welcome to Linear Algebra for Data Science. Lecture 2, Vectors and Basic Operations. Section 1, Definition and Representation of Vectors. This section covers vectors, a building block of linear algebra and a foundational concept for data science. In this section, first, I will provide explanation to understand vectors intuitively. Second, I will explain vectors mathematically. Third, I will provide the geometric meaning of vectors. Finally, I will explain how vectors is applied in data science. In simple terms, a vector is an ordered list of numbers. These numbers can represent anything from spatial coordinates to features in a dataset. We can use vectors to describe quantities with both magnitude and direction. In contrast, scalars are quantities that have only magnitude. We can visualize a vector as an arrow pointing from one point to another in space. The direction of the arrow represents the direction of the vector, and the length of the arrow represents its magnitude. Mathematically, a vector is a collection of numbers arranged in a specific order. For example, a vector v in two-dimensional space can be written in this way. Here, v1 and v2 are the components or elements of the vector. In more general terms, a vector v in n-dimensional space is represented in this way, where v1, v2, vn are the elements of the vector. Each element, vi, is a real number, and n represents the number of dimensions of the vector. Vectors can be classified based on their dimensions. Two-dimensional vectors are vectors with two elements. They are commonly used to represent points or directions in a two-dimensional plane. 3D vectors are vectors with three elements. They are used to represent points or directions in three-dimensional space. N-dimensional vectors are vectors with n elements, where n can be any positive integer. These vectors are often used in machine learning to represent data points with multiple features. We can visually represent vectors as arrows in space. For example, in a two-dimensional space, we can represent this vector as an arrow starting at the origin and ending at a point. The length of the arrow corresponds to the vector's magnitude, and the direction of the arrow shows the vector's direction. The magnitude of a vector represents how long the vector is. Magnitude is also called norm. For a two-dimensional vector, the magnitude can be computed using the Pythagorean theorem. For an n-dimensional vector, the magnitude is computed in this way. The magnitude gives us a sense of how far the vector extends from the origin in space. The direction of a vector is given by the angle it makes with the coordinate axis. In a two-dimensional space, a vector's direction can be represented using an angle theta with the x-axis. So, in this example, the angle theta can be represented in this way. Arctan is the inverse function of tangent. It is used to find the angle corresponding to a given value of tangent. Vectors are used extensively in data science and machine learning for various purposes. The first is feature representation. In machine learning, Data points are often represented as vectors, where each element of the vector corresponds to a feature of the data point. For example, in a dataset containing information about houses, a vector might represent a house with features such as size, number of bedrooms, and a price. The second is distance measures. Vectors are used to calculate distances between data points. The Euclidean distance between two vectors is a common distance measure, calculated as the magnitude of the difference between two vectors. The third is transformation and projections. Vectors are used in transformations and projections, which are crucial in various machine learning algorithms, including dimensionality reduction techniques like principal component analysis. Let's wrap up. Vectors are a foundational concept in linear algebra, and understanding vectors is essential for anyone studying data science and machine learning. In this section, we have defined what vectors are, explained how to represent vectors mathematically and geometrically, and discussed their applications. Understanding vectors will set the stage for a deeper understanding in subsequent lectures as we delve into more complex linear algebra concepts and their applications. Thank you for watching. Please thumbs up and subscribe to my channel.